There are so many different ways to connect your computer to a network of some kind. It might be a wired network, it might be wireless, there might be dial-up lines, you might be using a VPN. And fortunately, there is a central place you can go in Windows to help set up these network connections. If you go to the control panel, there is an option for Network and Sharing Center, and inside of that, you can set up a connection or a network. This is a step-by-step wizard. It will take you through the process of configuring and setting up these connections, and you'll get confirmations that the connection has been set up because Windows will perform some tests for you. You'll be able to connect through direct connections, VPN, dial-up. There are a lot of different configuration options in here, so you don't have to worry about the details. You simply follow the step-by-step instructions and you can connect your computer to that particular network configuration. It's very common for us to have a wired connection where we would take an Ethernet cable and plug it into a physical Ethernet port that's on our computer or our laptop device. This direct connection is usually the fastest one. So if you have multiple network connections on your computer, it's going to choose whichever one is fastest to be able to send that traffic out. You're generally not able to use multiple interfaces at the same time. Windows finds one interface to use and it uses that one until that interface is no longer available. If you're configuring your Ethernet connection, you can see that you can define an IP protocol configuration, for instance, the IP version 4. There's also a tab here for alternate configuration. If you find that a DHCP server is not available on a network, well, that means you're not going to get an automatic IP address configuration. So you can tell Windows when that happens, use this IP address configuration instead. That way you may want to set up a config where you leave the office and you connect to a network that doesn't have a DHCP server, but you already have defined what that IP address configuration happens to be. Our devices these days aren't limited to just wired connectivity. We're doing everything over wireless now. And if you look at the wireless configuration on your computer, you'll look for a network name. Behind the scenes, this is really something called an SSID, which stands for Service Set Identification. In your Windows configuration, you not only need to provide that network name, but you also need to provide a security type. This is going to match whatever the encryption configuration is on the access point that you're connecting to. If you aren't quite sure what this setting is, make sure you contact your network administrator because the configuration in Windows needs to match the configuration that's on the access point. You also need to set the encryption type for this. Again, make sure you match whatever the encryption type is on that access point. And lastly, you'll need a key. The security key can be something that everyone shares. We call those a PSK or a pre-shared key, but in a larger environment, you tend to have this configured to use your username and password, the same one you would normally use to log on to the network. That's using something called WPA2 Enterprise. It uses 802.1x authentication to automatically authenticate you using that well-known username and password that you might normally use. This is also useful because that way everyone isn't sharing the same access password to be able to get onto the wireless network. It's much more secure when you're using that WPA2 Enterprise. If you're someone who travels a lot, you may be using a technology called WWAN or wireless wide area network technology. This is using mobile networks to be able to access the network. So you don't need a wireless access point. You're effectively using the same network that's being used by your mobile phones. This is using usually this small PCI interface, and it's got a connection on here for antennas, and it's embedded inside of your mobile device. That hardware adapter usually can be removed or replaced or added if you'd like to add that capability to your laptop. These usually require some type of third-party software. You can see the Verizon software here that's used to access this device and be able to connect to that wireless network. So usually you're combining both the hardware and the software together to be able to give you this capability. So now you don't have to worry about connecting to an 802.11 wireless network somewhere. You can simply take your laptop anywhere you'd like and you're connected to the network. We don't see dial-up lines used extensively any longer, but there are certain applications where a dial-up line makes a lot of sense. And using existing phone lines that might be in a facility to be able to connect to another device that's also connected to these phone lines. The configurations usually require a username and password, and obviously you need a phone line because you're plugging directly into your computer, and your computer is going to be dialing that phone number and hopefully connecting to a modem that's on the other side. Once you've configure this dial-up connection, it appears just like any other network under your network status icon. The same way you would connect to a wireless network, the same way you would configure settings for your wired Ethernet network is exactly the same place that you would use to connect and disconnect from that dial-up connection. If you're traveling in the field, you've got a wireless connection in a hotel or in a coffee shop, but you'd still like to access information back in your corporate environment, you may want to take advantage of a built-in technology inside of Windows called a virtual private network. This VPN technology usually requires that somewhere along the line is a VPN concentrator. This is a piece of hardware that's responsible for taking the encrypted information you're sending it and then decrypting it and sending it into your corporate network and reversing the process when it goes back to you. That way you can communicate and get your secure files back at your corporate environment. But if anybody was to listen into that communication between the concentrator and your laptop, all they would see was encrypted data. Windows includes a built-in VPN client that allows you to connect without loading additional software onto your computer. You simply define the internet connection for your VPN concentrator, and you would then tell it if you're using a particular smart card, maybe allow other people on your computer to use this connection, or maybe don't connect right now, we'll choose to connect at some later time. When you're connecting, it's going to ask you for authentication. You'll need to provide a username and password. You might also have to provide other information, things like a smart card that you'd have to slide into your laptop. Maybe there's a token generator to provide a different type of access. Maybe your laptop has a fingerprint reader for biometrics. So you've got this multi-factor authentication of something you know, like your username and password, something you have, like your smart card, and something you are, like your fingerprint. Just like any other network connection, to enable or disable the VPN, simply access it through the network resources on the network icon that's in your taskbar. That automatic configuration. If you're configuring an IP address on your computer to access the internet, then you probably need a minimum of at least three things. One is an IP address. You need a unique address that no one else is using on the network. You also need to define a subnet mask. This identifies what subnet your computer happens to be a member of. And the third piece you'll need is the default gateway. This tells the computer that if you need to communicate outside of your subnet, where's the router for this subnet? How can you get off of this subnet and talk to other devices that are beyond your local network? If you're also talking to devices on the internet, then you're probably accessing them with a name. You're probably accessing google.com or yahoo.com. Well, obviously, we don't have an IP address for those. We simply type in google.com, and behind the scenes, your computer determines what IP address that happens to be matched with by accessing a domain name server. That DNS server has to be configured in your computer so that it knows where to go and receive that mapping of name to IP address. If you're looking at your IP configuration and none of these things are filled in, then it may be configured to obtain an IP address automatically. And if it does that, it's using a protocol called DHCP. That stands for Dynamic Host Configuration Protocol. Somewhere on your network is a DHCP server that listens for devices that are connecting to the network, and it's in charge of assigning those IP addresses to your device automatically. That way you don't have to go to everybody's computer and statically assign IP addresses and hope that nobody conflicts with anyone else. The DHCP server handles all of that for you. There's also another important address on your computer called the loopback address. Its default IP address is 127.0.0.1, and everybody has on their computer that loopback address. That way, if you're trying to diagnose things on a local computer, you can see if the IP stack is working properly by trying to ping that particular IP address. Let's look at our IP configuration. This happens to be my Windows 7 device. I'm going to choose my control panel, and let's move down to Network and Sharing Center, and you can see all of the configurations I have for my computer talking to the network and out to the internet. Let's go to Change Adapter Settings, and it pulls up a list of all of the adapters on your computer. And in my case, there is only one adapter. If I right mouse click this adapter, I can choose the status. We can see that we are connected to the internet over IP version 4, and if I hit the details, it will even show me the IP version 4 address. There's your IP address. There's your subnet mask, 255.255.255.0. There's my default gateway, which is 10.1.10.1, and there's the DNS servers. So I can see all of the information has been assigned to me automatically from my DHCP server, and I can see what the values are for each one of those settings. But what if we didn't want to use those values? What if we wanted to type in our own information? I'm going to close that. Instead of the details here, I'm going to choose the properties for this device, and I'm going to look at my IP version 4 information and choose the properties of that. In my configuration, this is set to obtain an IP address automatically, but I could also choose to statically define what I would like this address to be. You may have to discuss the details with your network administrator or define exactly what you would like to have, and then manually add in the different configurations for your IP address, your subnet mask, your default gateway, and your DNS. There's also another setting inside of this called the advanced, so you could change IP address information, DNS information, Windows name services details in here as well. By changing the properties of this adapter, it takes effect immediately. So when you click OK and go back to the main screen, you're now using that new IP address. And if you got something wrong, you want it to revert back, you can always drill down into the properties again, choose to obtain an IP address automatically, and when you click OK, everything will revert back to that automatic configuration. That allows you to put in your username. When you start up your Windows operating system, if you don't have the auto login capability enabled, then you'll be presented with a view that allows you to put in your username and your password. That is accessing a list of users that's defined in the operating system. On top of that, there's a list of groups that these users can be members of. And if you need to set administrative access to certain files, directories, or other resources, you can assign entire groups of people at one time by taking advantage of that functionality. Inside of Windows, if we go to our computer management, you can see there is a list of users and groups local to your computer. There are some users that are added automatically to the operating system. One is the administrator user. That is someone who is the super user throughout the operating system. They can do anything to the OS. There's also a guest user that is configured automatically. Usually it's also disabled by default, but it's one that assigns just some basic access to your computer. Generally, it's one that's not often used, but if you need a generic login for users, that might be a good way to do it. You also, of course, have regular users, usernames that might be logging onto your computer. For instance, the user professor, that's my login to log into my Windows environment, and that gives me the access to the resources that I need, but doesn't give me, for instance, administrative access by default. If you have certain users you would like to also provide that administrative access, there are certain groups for administrators that you can add that access so that that is limited to just the people who need that capability. You can, of course, create your own groups in the operating system, but there are a number of groups that are available. One common one that you'll see is the power users, which generally sound very good, but there's really not that much more access to your operating system than what a normal user might have. But if you wanted to create your own groups that provided access to a printer that's on your operating system or to a particular shared directory that's on your computer, that's a great way to manage that process, especially for large groups of people. If you wanted to provide access to a set of files or folders on your computer from somebody across the network, then you would configure something called a Windows share. There are some shares that are already predefined on your computer when you install the Windows operating system. These are administrative shares, and they're generally hidden. The way that you would see a hidden share is there's a $sign that's right after the share, and those are shares that are created automatically during the installation of the operating system. You may find, for instance, that your entire drive is configured as a share. C $, for instance, accesses everything on your drive. Another one is just for administrators. The admin $sign is for the Windows directory so that you can perform administrative tasks to everybody's Windows system, regardless of where they might happen to be on the network. You can see all of the shares and the configurations of those shares in your computer management under shared folders. You could also, at the command line, simply type in netshare and you'll get a summary of the shares, the resources associated with those shares, and any remarks that were created when that share was built. The NTFS file system is very powerful and allows us a lot of flexibility for allowing or disallowing access to certain files or folders on the file system. If we were to look at the file system in NTFS, you can see all of these different permissions are available for the users on your computer. You can set full control, modify settings, read and execute, list folder contents, read, write. There's other permissions as well. This is a very flexible permission system that's built into the file system. So if somebody was to sit down at your computer and log in with their username and password, they would have permission to those files configured in the NTFS file system. But of course, somebody doesn't have to be sitting at your computer to access files. We're connecting to the network and we're building out these shares. There is a completely different set of rights and permissions for shares. For instance, here's the same directory and the share permissions for everyone, and we can set full control, change, or read permissions. Notice that's very different than the permissions we had available for NTFS. So now there becomes a question. If we access these files through the network, we not only have share permissions, but we also have NTFS permissions that we have to take into account, and we have to take them both into account simultaneously. NTFS permissions are part of the file system of the computer. That means if you're sitting at the computer, those NTFS file permissions will apply to you. If you're accessing those files from across the network, those NTFS permissions will also apply to you. Anybody accessing those files have to go to the file system, and therefore the NTFS permissions will apply. If you're coming in from across the network, those share permissions will also apply to you. So you're combining those two things together. So you not only have to think about all of the permissions for NTFS, but if you're coming across the network, you also have to look at those share permissions. The most restrictive permission will always win. So if you set up access to a directory of completely wide open access to read and write in NTFS, and somebody uses that share across the network and the share permission is set to only read, the default permission for everything is going to be read-only across the network. You'd have to be on the local computer to be able to have full access. The share permission is more restrictive, therefore that is the one that's going to apply. When we're organizing files and folders on our computer, we might put folders within folders within folders. And in those cases, the permissions are going to be inherited from the top object all the way through all of the other folders. So if you define it at the top of the folder tree, you're going to automatically see those permissions all the way through that particular tree. They're all going to be based on that parent object. If you take those files and you copy them to a different volume, all of those permissions are going to be reset to whatever is on that other volume. If you move them on the same volume, however, they maintain all of those permissions that you've set. In Windows, when you move something on the same volume, it simply resets a pointer. When you move to a different volume, it's physically copying the files. So keep that in mind as you're setting permissions. If you copy them to another folder and you realize your permissions were reset, that's because you created a new copy of the file and therefore you have different permissions. Those NTFS permissions and share permissions wouldn't be useful if we didn't have some way to authenticate people into the operating system. We want to be sure the people using these resources is the real person. So normally you have to have a username and a password at a bare minimum. You might have other authentication requirements as well. You might have to add a smart card to your computer or do a fingerprint scan just to prove that you are the person that you say you are. There are a number of capabilities in the Windows operating system to also provide single sign-on capabilities, and we generally see this on a Windows domain. When you log on to a Windows domain, it knows that you're you regardless of what resources you access. So if you go and access a printer, if you share files on one server, if you share files on the other server, you're not constantly asked for that username and password process over and over and over again. In a domain, when you log in, it's a single sign-on. Once you log in, you're never prompted again. And that is the experience we want for our end users. We want them to authenticate once and have access to all of the resources that are appropriate for them. Our browsers have become one of the most important applications on our computing devices, and the bad guys know this. And they're trying to feed ads to you and get malware, and they know that the browser is a great place to do that. One thing you'll notice on a website is you might get a pop-up message. Usually it's an advertisement of some kind. Sometimes it's just a single pop-up. Sometimes it is many pop-ups on your screen. Obviously, if you're starting to see a large number of pop-ups and it seems like it's not really a normal amount, you may be infected with some malware. That's a great way the bad guys use to pop up a message on your screen, get those ads in front of you so that they can make some money behind the scenes. Another interesting tack that's used is that the bad guys will try to make the pop-ups look like an absolutely legitimate application. It may pop up and tell you that you need to update the version of Flash on your computer. Please click here, and you're actually now installing malware instead of updating your Flash. Another technique used by the bad guys is a browser redirection. This is when you are performing a search that's in Google or Bing or your search engine that you'd like to use, and you see something that you would like to follow. You click on that option, and instead of going to that Google result, you're actually redirected to another site. The bad guys are sending you somewhere completely different than what you clicked on, so you are being redirected to that other site. It's usually a virus or malware that's causing this. This obviously isn't something that's normal for a computer, and it's because the bad guys like to take you first to a site that's going to prompt you for an ad, and at that point they might even take you to your ultimate Google selection, but first you had to go through their site so that they would make money putting ads in front of you. Another concern in our browser is when we get one of these security alerts popping up. Here's one, for instance, that tells us that the site we're using, the site security certificate, is not trusted. We're trying to communicate through an encrypted link to that particular site, but the certificate on that site isn't something that our browser trusts. Our end users have gotten so accustomed to simply clicking through this, but this could point to a significant security problem. So you need to drill down into the details and find out more about what the user is seeing when they go to this site. This could be something simple like the website certificate happens to be configured improperly, or it could be that there is someone in the middle of this conversation that is decrypting the information or proxying that information. And when that happens, you could get messages like this. So if you're running into those types of situations, it might be worthwhile to take a moment, drill down into the message that's popping up, do a little bit of research, and make sure that you're not having any big security problem. If malware is on your machine and you are infected, you may see a number of problems. One is just slow performance, or your system is locking up. If you're starting up your computer and it's taking forever for your system to boot up, it might be pointing towards some type of malware infection. These folks that write the malware code aren't doing a lot of quality assurance. They're not doing a lot of testing. So you might run into situations where the malware in their side ran great, but when it's running on your side, you're really noticing that there's a problem. And when that happens, now nothing is really going to run well on your computer. You might also have problems with network access. The malware itself wants to limit or direct your computer to certain places on the internet, and it doesn't want you to go to sites where there are known malware cleaners. So it's going to prevent you from going to those well-known antivirus sites. It wants to control exactly where you go and exactly what you see on your screen. So if you can't download the fix for this malware problem, obviously the malware is going to stay on your computer. So the malware authors have gotten very good at preventing you from using the network in the way that you should. You might also notice that your Windows Update isn't working any longer. Obviously, the Windows updates are going to include things like security patches, and the bad guys don't want you patching your system. They want it to be as susceptible as possible, and they don't want you to find any problems or clean those problems by performing one of these Windows updates. The malware authors are usually finding multiple ways into your system, and if we perform a Windows update, your system's going to start closing those doors and prevent them from getting back onto your computer. Another symptom you may notice is that the system files themselves have been changed. You might get error messages when you try to start certain applications because the malware authors don't want you running those apps. You might see files disappearing completely, or files might be encrypted suddenly that you didn't encrypt. The malware authors are going to have complete control. Once they're on your system, they can change any of the files that are on your computer. They can also change the permissions of the files. The malware authors don't want you deleting the malware once it's on your system. They're going to change registry entries. They're going to add new files. They're going to modify files in your system, and they're going to change the permissions so that it's going to be very, very difficult for you to recover from those changes. That means once you start trying to remove some of these files, you will see that you don't have access to do it. The malware has already modified itself to lock you out of making any changes and removing that malware from your system. One of the easiest ways for the malware authors to infect a system is to get you to infect it. That way they don't need a lot of special backdoors to get into your system. They'll have you click on a message, and it might be a message that says that your system is infected and you need to click here to install some antivirus software. And of course, that's not really antivirus software. That's really malware that you're installing. Sometimes you'll see hoax messages pop up. Once the malware is on your system, you may see something like these messages here that say your computer's been locked. We have seen information on your computer that's illegal. You have to pay the fine immediately. And they give you a lot of options at the bottom of where you can go to take your money and send it directly to the malware authors. And this looks legitimate. There is a Department of Justice Federal Bureau of Investigation logo right on here. It looks as if it could be legitimate. But of course, the federal government in the United States isn't going to ask you to wire the money directly. This is obviously a hoax. And part of the problem is that your system is now locked. You don't have access to your system any longer. You have to wire the money in the hopes that they're going to give you the code that's going to unlock your system. Obviously, then you have to run some type of specialized removal tool to get rid of this application. Sometimes there are other techniques you can use, and the bad guys have gotten very, very good at finding ways to embed themselves into your operating system and make it very difficult for you to remove these. Unsolicited email is obviously a significant problem. We have a lot of spam that's flying around the internet, and part of the problem isn't just that some of this happens to be advertisements, it's that some of this spam includes malicious attacks. It may be someone who's trying to get you to input your username and password to a particular site by posing as that site. Maybe there is malware included into the message itself, or by clicking a link, it's going to take you to a site that then installs malware onto your system. This is a very, very common way for the bad guys to get embedded onto people's workstations, so you have to be very careful about what you're clicking inside of an email message. Obviously, once the bad guys have gained access to your system, they can do a lot of things with it. You might become a source for sending spam yourself. It's very difficult for the bad guys to send spam because as soon as you would see that spam being sent, they can be turned off by their internet service provider. But if they can have your computer send an email message once an hour or twice an hour, they could have a massive email network running that's practically undetectable. Your computer might also now be controllable from a third-party location. Your system simply checks into a centralized server, which gives your computer the instructions of what to do next. So if somebody wanted to take down a site through a distributed denial of service attack, your computer now may be one of the spots that's originating some of those attacks.